Alright, so in this video I wanted to show you a brief explanation of a transverse wave in the form of a graph. Now, hopefully based off of the reading and the notes that you've looked at in the supplemental material folder, you should be able to, at the very least, be able to identify the parts of this type of wave. So here, this top part here labeled X, as well as this top part here, the highest points of these types of graphs are known as crests, and the lowest points of the graphs are known as troughs. Okay, so in a transverse wave, you've got a crest and a trough. Another part of the wave that you'll need to be able to identify is what we call the amplitude. And the amplitude measures the height of a transverse wave. So we measure the height of a wave starting at this median line, okay, this equilibrium line right here. And we can either measure from this line to the highest point of the crest or from this line to the lowest point within a trough. And what you should hopefully notice is that the displacement from either this equilibrium line to a trough or the equilibrium line to the crest is the same length, the same distance. Okay, so this from here to here, and then from here to here, these two sections both measure amplitude. Okay, so you can pick either one. Just know that both of them are going to measure the same distance. So let's say that this graph was marked, and let's say got a marking there, 2, 3, 4, 5. And then we can count our time in seconds. Let's say this is 1. This is 2, 3, 4 seconds. Measures my time across the y-axis. I'm sorry, excuse me, the x-axis. I can't get that S. There we go. All right. So if I ask to, or if you're asked to measure the amplitude of this wave, you would simply determine that the wave is measured, the amplitude of the wave is measured from the equilibrium line to either a crest or that same equilibrium line to a trough, and we can number them down this way: 1, 2, 3, 4. So this would be, let's say this is -4. All right, so the equilibrium line to the highest point here, say that's the highest point, I would say that's probably about 4. From the equilibrium line to the trough, I would say is also about 4, but in a different direction. So normally we would just say the amplitude is 4. And you can measure it in whatever units your y-axis is measured in, meters, centimeters, so forth. So the amplitude has a energy level of about 4. So how many wavelengths would this graph be? So how do you determine wavelength? Well, let's say that my graph starts here, which it does. Now, I want to measure from that point that it starts at to the same point on the next consecutive wave. Okay, so about this point it starts at the equilibrium line, and it's at the beginning of a crest. So this point is followed by a crest. So if I go across here and I follow this crest up to this next point where the line crosses my equilibrium line, yes, this is a point of intersection. However, this point is at the beginning of a trough. So this is not the same point on the next wave. So I would go from this crest to this trough, follow to this point, And now at here, at this point, now this is the beginning of the next crest. Just like this point was the beginning of this crest, this point is the beginning of the next crest. So this marks one wave cycle. So the next wave cycle would be from the beginning of this next crest, up, down, back up to here. And if there were another wave continued on, this would be the beginning of another crest. Okay? But there is no wave there, so that's where our wave stops. Okay? So we measured from this point to this point. This marks one wavelength. And from here to here, this measures one wavelength. So all in all, this wave has a total length of 2 wavelengths. There's 2 full waves in this graph. So one of the other things that you were asked is to determine the wave's frequency. Okay, frequency is the number of cycles divided by time. So if I go ahead and relabel my x-axis, we'll say this is 1, this is 2, 3, and 4 seconds. All right, so frequency is the number of cycles, in other words, the number of waves, and is divided by time. Okay, so how many waves did we count? Well, from here to here, that's one wave. From here to here, that's my second wave. So there are 2 cycles or 2 waves in this graph. So my number of cycles is 2. And the time it takes to complete 2 cycles. Well, if I start at 0, here's 1 second, 2 seconds, 3 seconds, and 4 seconds. Excuse me. So 2 waves pass by in 4 seconds. So the frequency is 2 divided by 4, which is 0.5. And we measure frequency in hertz. So the frequency of this wave is 0.5 hertz. So in other words, there are half of a wave being passed every single second. Okay, so after 1 second, this is half of a wave. And from 1 to 2 seconds, this is half of a wave. Half of a wave. Half of a wave. Half of a wave passes every single second, which gives me 0.5 hertz as the frequency of this wave.